Welcome to Constellations, the podcast from Kratos. My name is John Gilroy, and I'll be your moderator. Our guest today is Melanie Stricklan, co-founder and CEO of Slingshot Aerospace. Melanie is a 21-year Air Force veteran, as well as co-founder and CEO of Slingshot Aerospace. She provides her insights on the benefits of space data for decision-making in space situational awareness, sustainability, interoperability, and virtualization across the space data landscape. She does this to enable LEO sources. Melanie is no stranger to the space domain. She was recently recognized as one of Inc.'s top 100 female founders, and shortly thereafter, her company Slingshot was named to Fast Company's annual list of the world's most innovative companies for 2021. The right information at the right time, all in one place, is key to successful responsive operations around the world. Collective data sets from the most critical sources provide a complete picture to commercial and defense entities for mutually beneficial decision-making. Melanie, so what's your perspective on the current state of our orbits in space?
Yeah, thanks for having me. And my perspective on our current orbits in space are, we are in midst of a space revolution like I've never seen. And I think maybe even more than back in the 60s. So 87 countries, 10,000 companies launching, operating spacecraft, private human spaceflight, off-Earth manning, interplanetary travel, moon bases, space stations, and maybe even some hotels on orbit. So there's a lot going on up there. Whenever I left or retired rather from the Air Force, we were tracking about 1,800 satellites, operational satellites. And today our software is tracking a little over 7,000. And we're on track to have about 115,000 operational satellites by 2030. And that's just, modeling off of what has been, applied for licensing and those types of things. But the vast majority of space investment today still goes into hardware. So more rockets, more satellites, more ground stations, more components, which is a good thing. But I do believe that there's a lot of uncertainty going on orbit today, whether that is from exponential growth in those launches of satellites and mega constellations coming to bear, uncontrolled space debris, major coverage gaps with different nations, different providers, different schemas, different models, crowded spectrum, aggressive behavior geopolitically. And the fact is we've got a problem. And it's really just uncertainty, not necessarily the world's falling apart or the sky's falling rather, but we've created a bit of a wild, wild west and we need to tame that by reducing the uncertainty.
A guy named Simon Sinek is famous for asking the question, why? So I got to drop a why on you here, So we know thousands and thousands of satellites are projected here by 2030. So what are the drivers for all this growth, especially in LEO?
Yeah, I think the drivers are transparent pricing on launch. Launch used to be the most expensive thing. But it's now in a place that allows for, lots of folks to hop on a rocket and get to space and understand the pricing and understand that anyone across the globe can launch a satellite today, whether you're a small academic or a STEM group or a high school group or a company that has always had the passion to do something on orbit to increase or improve humanity here. So that's one avenue. The other is just Moore's Law, more COTS capability that has been matured and scaled through, use of smartphones and those types of things have also enabled our space industry to leverage those and get capability on a LEO path a lot faster. Resiliency of those types of proliferated LEO constellations prove valuable when it comes to the comparison of that versus, monolithic satellites that cost millions, if not hundreds of millions of dollars and are built over years and years and years so that they can operate years and years and years. So it's just a complete paradigm shift in how we think about our architectures on orbit and on the ground.
Earlier, you mentioned the 1960s. I think there's going to be a TV show called Lost in Space in the 1960s. I think they should rebrand it Crash in Space. I mean, thousands and thousands and thousands and thousands out there. I mean, so what are the causes and effects of some of these collisions in orbits?
I think there's the simple answer, right? Which is as we get closer to the 115 satellites. Matter of fact, I think there was a study recently that said the inflection point is around 40,000 in low Earth orbit. But we will start to have more collisions, and those collisions can lead to a cascade event called the Kessler syndrome. And if that were to happen, that could deem our orbits unusable, not for a year or 2 years, but for potentially tens to hundreds of years. And so we don't want that to happen. That's one big risk. The other risk, I think, is more readily seen, and that is some of the operational efficiencies around understanding thresholding when it comes to collisions and mitigating that risk, mitigating spectrum interference. Spectrum's getting pretty crowded today. So, the more objects that go up on orbit, and without a digital opportunity to deconflict what I call space, like airspace, but for space, then I think we get closer to those inflection points that will render us a non-spacefaring world.
Space. I'll have to remember that one. That's a good one. Melanie, there are some concerns now about the sustainability of all these projected launches, particularly in LEO. In a recent panel session on the 36th Space Symposium, a group discussed the management of the physical room in space in the LEO orbit. You just mentioned that earlier. And there's no rules, apparently, who gets space and how much it's used. A recent study by a company in the DC area called MITRE, on behalf of the Science Foundation, found that the current projections for launches are not sustainable for a variety of reasons. So what do you feel can be done to support sustainability in our orbits and manage who gets what?
I used to think that the first step was space sustainability from an international effort for more regulation. But I think that that's failed and failed again. And if we want governments to truly figure this out and prevent those types of disasters, then what we have to do is look at different ways, different, more progressive ways for the industry, whether it's civil, commercial, or government, to better collaborate across borders. As you know, space has no jurisdiction, right? There's no regional jurisdiction like airspace. And so we need the ability to communicate, collaborate, and coordinate across civil, commercial, and defense organizations globally. And I believe that those types of tools that connect our operators across those different organizations will help get us towards space sustainability faster, cheaper, and better. I come from the government, so I have faith that the government can be world-class, but I haven't seen, a huge stride in truly taking those steps towards ultimate space sustainability. So I think it's time for the community that operates in space to come together and solve the problem ourselves.
About 2 hours ago, I went to your LinkedIn profile. Whoa, you've got a long history of space data. Can you tell us more about data sources are necessary for real-time decision-making and how they work together?
Yeah, for sure. So the space domain has many different orbits. So the closer you are to Earth, the faster you go. Further away, the slower you go. And there's different phenomenologies, whether it be radar, optical, RF, that observe these different orbital domains or orbital regions, so to speak. And so when it comes to data, to be able to bring, multiple data sources together, whether, that's radar that works really, really good at the low Earth orbit, or optical that works really, really well way out at GEO, to bring that type of data together. There are no standards today for space situational awareness data. And so one has to curate and normalize that type of data in order to get a more holistic view of what's going on orbit. And so that's something that we've been working on for several years here at Slingshot, is how do you curate and normalize that and make an ensemble virtualization environment of the actual space operating domain from low Earth orbit out to cislunar, and hopefully in the future, even interplanetary. But to do that, you have to understand the phenomenologies that work best at certain altitudes and those that can see, 24/7 versus those that can only collect at night. And so it's a big opportunity for the industry, but it's also a very complicated set of technological feats that have to come together to make the holistic common operational picture for the space domain.
Phenomenologies. I haven't used that word since I was in college in philosophy class. Wow, that's a pretty impressive word. Phenomenologies. Well, I guess that's a good way to describe it, though. You think your company recently launched new software technology that can help space industry collaborate and share data and avoid collisions in space. Can you tell us about that technology and how it came to be?
Yeah, so I believe you're talking about Slingshot Beacon. Slingshot Beacon was inspired by a few different things. One, whenever I used to fly on JSTARS back in the day, before we stepped to the jet, we had to read all of the NOTAMs and those notifications to airmen. And whether you're commercial, civil, or a defense air crew, you have to understand where to fly, where not to fly. And that's a dynamic situation. Hey, the air box out by Huntington Beach is going to be used for air show over this weekend, so let's not fly there, right? Those are sent out globally, and that does not exist for space, number one. So how can owner operators inform one another that they're going to be orbit raising, or they're going to be doing a out of sequence maneuver that may have placed them somewhere in harm's way or in your flight path? And so that was number one. That's how that was the first thing that we started thinking through. And then the second was also from my time flying, we had what was called guard channels. And those guard channels were up all the time. They're global frequencies that if you're in the air, you're monitoring. There's something like that in Marine as well. But I think, understanding that people have to communicate around deconflicting risk. And so the space world also has no guard channel. So could we bring those two ideas together at the same time, bring a virtualized world together that maps and understands positional knowledge, weather knowledge, spectrum knowledge, so that our owner operators have all of that information along with business logic knowledge that triggers at the right time in the right place, so that these companies can talk to one another and deconflict their airspace in a secure, trusted global communication platform for operators to do that and to plan outcomes and to just make better decisions around their operations. To do that, complexities therein are around business logic, like different companies have different thresholds for when they want to address a potential conjunction and when they want to maneuver and those different things. So it's not just a secure chat that throws two companies or organizations together in a room to work it out. There's a lot under the hood, from all of those phenomenologies that we talked about earlier to advanced astro to AI and ML, with insights that scale very modularly, but do scale. And so there's a lot going on in Slingshot Beacon today, but with all of that comes the ability to optimize operations across the space industry.
Well, you just said the phrase that pays: artificial intelligence, AI, and ML, machine learning. And so when I was taking notes as you were speaking, and I was like running out of ink with the complexity here. I mean, this and that, and all of the business. And so you have to use these modern types of technologies in order to be efficient. You have to use AI because it's so complex, don't you?
Yeah, we have to. So it really kind of starts with machine learning and deep learning. But what we found is when we use AI and machine learning combined with high power compute in that confluence, we can rapidly extract information around the vast amounts of information that we're pulling in. And earlier we mentioned a whole lot of phenomenologies around observation, but there's other contextual information that also comes in to play there. And so our technologies use all of that vast amount of information and combine that with machine learning to characterize space object, detect threats, enable confident decision making, all of those things. But here's the kicker. There are not a whole lot of collisions to train those AI models from. So we've had to be very proactive and build out a simulation capability that actually helps us, overcome observed imprecisions, right? And insufficient SSA force modeling and unknown and unmodeled events, right? So like an unknown space weather event or an unknown maneuver or unknown breakup or fragmentation. So those undersampled observations and algorithmic deficiencies can be overcome with some of the simulated data that we've brought into the equation here.
You know, Melanie, thousands of people from all over the world have listened to this podcast. Go to Google and type in Constellations Podcast to get to our show notes page. Here, you can get transcripts for all 100 plus interviews. Also, you can sign up for free email notifications for future podcasts. Melanie, apparently there are some space industry big hitters piloting this software. Are you able to share anything about what their hopes and goals are as they move forward utilizing your technology?
Yeah, so I think each one of our customers wants to optimize their operations and reduce the probability of accidents. No one wants to be that guy or that gal who caused an irreversible event, right? And so Slingshot Beacon from the beginning has had just an immense amount of magnetism. And we're super happy that we are there to be that first collaboration and coordination platform to help mitigate those potential risks and facilitate safer and better satellite operations. Not only are our customers receiving that critical data in a more digestible way, but it enables them to make better decisions faster. But what we are getting from this is very important as well. So having those big hitters, as you called them, side saddle with us, we're getting very, very important feedback on what our customers' needs are as they're helping us as we continue to develop and mature the technology. So by having them all on this platform, I believe we are many, many, many steps further along in creating a safer, more sustainable space economy.
So I think I understand generally what you do. So what other problems can be solved with the software? And can like a military or commercial entity capitalize on this level of space data collaboration to benefit Earth and everyone on it?
Yeah. So, I think I heard this the other day. I believe someone said the average person touches space 30 times before breakfast and doesn't even know it. So our way of life has come to depend upon satellites that enable our cell phones, live stream sporting events, TV of any nature, really, GPS systems, ATM machines. The timing for all trades globally are either GNSS or GPS timing sourced. And it's imperative that we create a more scalable way of ensuring that these capabilities stay on orbit and that we can continue to progress humanity, leveraging space as a global tenet of our economy for generations to come. I think that other entities that could capitalize on the space data collaboration are anywhere from space mission design. So we'll stay on the space side for a little bit, but space systems manufacturing, the what if analysis that comes from digitizing the space domain is very powerful if you can get it into a place of what ifs. Like space moves really, really fast, but what if you could take any moment in time and play out a number of scenarios, bring your own models forward and play those out for optimal outcomes. And so when you start thinking on that level, you start thinking about insurance companies, you start thinking about autonomous space as a nervous system to that autonomous space traffic management system of the future. And I think, there's use cases that we don't even know yet. But the first step is to get that information in the right place with the analytics and capabilities to extract insights from it.
Melanie, in a recent interview you did with From the Top, you mentioned that virtualization and interoperability are important to support space sustainability and collaboration. Can you help us understand virtualization and the benefits of virtualization and interoperability? I think you talked about it a little bit. It's almost like a digital twin or have a sandbox to test things out. And is that what we're talking about here?
It is. The word virtualization really just means using software to simulate hardware functionality or processes. And so for me, virtualization means our orbital domains are actually full of hardware. They're full of other things like space weather and other events. And they are representative of processes. And so if we can simulate the hardware and the space that hardware flies within and the debris and the weather, then we've, in a nutshell, virtualized a different world, our orbital worlds. And so for us, it's important to do that for many, many, many different reasons. I think we've covered a lot of those today, but our vision and our passion is to accelerate space sustainability, and that is what virtualization paves the pathway for us.
I'm going to touch on communications a little bit now, communication with satellites. In addition to the proprietary way in which satellites communications is operated, for the most part still does today, what are some other challenges you've seen when working to facilitate data collaboration between so many different entities?
Yeah, I think although space has been democratized over the past several years, the game's completely changed for those who want to explore space and be part of space. At one point, it was just nation states, so they could really lock down data. They could really demand what sensors could look at and not look at. And so I think some of the challenges that we see today in facilitating data collaboration is truly around government entities and understanding where we can navigate and, the ITAR and EAR requirements on a company like Slingshot. And so working very, very closely with State Department on that to ensure that we stay well within our lane, but also bring forth to this global industry a global capability. For us, that means that we need to be able to bring in onboard data and other types of data from countries that may not just be on the allied list. And so we're working through what that means today. But there's room for all countries to be participatory in the advancement of space sustainability. And it really is an imperative.
Well, Melanie, we've hit so many different topics today. I've got to toss it to you and say, well, what are you excited about most when you think about the future in space? I mean, there's so much going on. I don't know how you can figure it out.
Oh my gosh. So I've been excited about space since I was a child, as long as I can remember. But what excites me today the most is just seeing how normal, average folks who have been also inspired since they were children by space can get involved with space. So with so many different companies around the world doing so many different things to leverage space as a portal of progress and unity. I loved watching the Inspiration 4 documentary not too long ago and just understanding, the power of, looking at the Earth from above for those types of folks who would have never dreamed of going to space. And so I think that, as we progress down the path of bringing more and more non-space folks forward that have a passion for this, the sky is no longer the limit, and we are going major places. And maybe one day the human race will be multi-planetary. Who knows? But I'm super excited about the stuff that's closer to the Earth right now.
Great. Melanie, it's really hard to get a handle on a topic that includes 100,000 satellites, but I think you've managed to achieve clarity in a complex environment. I'd like to thank our guest, Melanie Stricklan, co-founder and CEO of Slingshot Aerospace.
Thank you.